Okay guys, so we have one last thing to talk about in our unit of momentum. We're going to talk about explosions. An explosion is an interaction that forces two objects apart. So typically we have two objects that start as a system, and then something occurs in which these two objects are repelled in opposite directions. A classic example is usually a bullet inside of a gun. The example that we're going to do today is a bullet inside of a rifle. So our example, we have a 10-gram bullet is fired from a 3-kilogram rifle with a speed of 500 meters per second. What is the recoil speed of the rifle? So we know that the bullet and the rifle start as a system. Once the bullet is fired, we know that the bullet puts a force on the rifle, and the rifle puts a force on the bullet. Those forces are equal, but in opposite directions. Right, that's according to Newton's third law. Here we're looking at the momentum. So we will look at this through the lens of conservation of momentum. So I have my before and after sketch done out for us. So before, inside of the barrel of the gun, with a little black dot, which is a bullet. It starts as a system. So we're given the mass of our bullet in grams. We want to convert that to kilograms. So we're going to move the decimal place over 3 times to get the mass, which is going to be 0.01 kilograms. The mass of our rifle we're given is going to be 3 kilograms. Technically, before the bullet is shot, right, the system is at rest. The initial velocity of both the bullet and the rifle is 0. Okay, so right, with momentum, we simplify the system by looking at before and after the interaction. So let's look at after. After we have the bullet moving out of the barrel, we know that the bullet is moving at 500 meters per second. We also know that because of Newton's third law, that the rifle is going to recoil. We are trying to find the recoil velocity of our rifle. So what we need to do is set up a conservation of momentum problem. I'm going to do that on the other side of the board. I'm going to pause it quickly to avoid any motion sickness from me moving the camera. Feel free to pause the video at any point if I'm moving too fast or you need to copy something down. But we're going to use a conservation of momentum. P initial, momentum before the interaction equals P final, the momentum after the interaction. So we're going to put it in context of our bullet and our rifle. So the mass of the bullet times the initial velocity of the bullet plus the mass of the rifle times the initial velocity of the rifle is going to equal mass of the bullet times final velocity of the bullet plus the mass of the rifle times the final velocity of the rifle. So let's plug in what we know. So on the left side of our equation, we know that the initial velocity of both the bullet and the rifle will be 0. So the left side is going to be 0 plus 0. So we're going to simplify that to be 0. So 0 equals the mass of the bullet times final velocity of the bullet, which we know is going to be 0.01 kilograms times 500 meters per second. Plus the mass of the rifle, which we know is 3 kilograms, times the final velocity of the rifle, which we don't know, so we're going to leave it as a variable. Alright, so we're going to plug that into your calculator, 0.01 times 500, you're going to get 5. Units are kilograms, meters per second. Equal to 0. So we know here that if the bullet moves to the right, the rifle is going to move to the left. So we're going to get a negative value for our velocity of our rifle, which is what we want. Typically, you can plug in that mean here, but because it's set equal to 0, an explosion, well, the negative sign will just represent our direction. To remove that to the other side, we'll get negative 5 kilogram meters per second, then divide both sides by 3 kilograms of mass to get the velocity of the rifle by itself. So solve for the final velocity of the rifle, and you're going to get negative, I believe it's 1.67. Yep, 1.67 meters per second. So the recoil velocity of our rifle is going to be 1.67 meters per second, negative meaning to the left, the opposite direction of the bullet. Okay, so now what we're going to do is you're going to get the momentum, conservation of momentum activity from the substitute. On the top of that activity is a link to the simulation in which you're going to complete the lab. Okay? Once you're done with the lab, you're going to hand it in, put your name on top, put it in the big blue thing. In Classroom, on the momentum homework, I have updated, added problems for you to do. So in addition to number 1 to 5 in the textbook, you can also do the inelastic, elastic, and explosion problems. Okay? You'll also have time tomorrow in class to do those. Alrighty. Send me any emails if you have a question. And this exact problem is in your textbook in Chapter 9. It's section, I believe, 9.6. Okay. That's all.